In example 2.1 part E, we're looking at the equation y equals x to the 4. Very similar to what we had with x cubed as well as x squared, but it will be more similar to x squared than it is to x cubed. That's because this is an even power, just like what we had with the squaring function. This has a name. It is called the quartic function. You might think of a quarter. There's 4 quarters in a dollar. And here you can see we have a power of 4 using the word quartic. For the function definition, again, I'll call this f. No reason that we can't use any real number and raise it to the 4th power. So we'll use that as our largest possible domain. And this will be given by the equation f of x equals x raised to the 4. So we can pick x values, and I will select -2, -1, 0, 1, and 2. And f of x for the second column, -2 should map to 16, positive 16. -1 will map to positive 1, 0 to 0, 1 to 1, and 2 will map to 16. Now, this one's a little difficult because we're not going to be able to use all the points we just created on the coordinate grid that's provided here. This one does not go all the way to 16. So we got to be a little bit careful about the way that we graph the curve, because we want to make sure that we understand that even though we can't plot the points, we need to accurately represent that the points could be there. So here's what I do. I'll plot -1, 1, 0, 0, and 1, 1. Now I know that 216 is going to be something way up here towards the top of the grid, and that's probably not even far enough. It might even be a little bit further off the page. But that gives me at least an idea of where this thing needs to be going. So when I draw the right side, starting from the origin, it's going to end up creating more of a U shape. And it looks a little bit more like this. And then the left half will look identical, and it'll look like this. So we get a little bit more of a U shape than we do with the squaring function, and this is called the quartic function.